Hello everyone, welcome to Vardhaman College of Engineering. I am Dr. A. Kishore Kumar, Assistant Professor, Department of Chemistry. In Engineering Chemistry course, we have water and its treatment. In this module, today we are going to discuss boiler troubles. In that, sludges, scales, and caustic embrittlement. Today we are going to cover, right? So there are other boiler troubles are there like priming, foaming along with this scale, sludge and caustic embrittlement. But today we are going to cover boiler troubles due to sludges, scales and due to caustic embrittlement, right? So first we should know what is the importance of boiler, right? So to know that thing, we should have an idea of thermal power production. So boiler plays a crucial role and important role in thermal power production. So this is what how electricity generates in thermal power production. Here you can observe. So this component is called as a boiler. So this is called as boiler, right? So in thermal power production, steam generation of steam is important. So that steam hits the turbine blades. So here you can observe turbine. So these are turbine blades, right? So steam hits the turbine blades, right? Then turbine blades starts rotation that is connected to electrical generator where electricity produces, right? So that electricity with the help of suppliers we can use for domestic and industrial uses, right? So here how we are getting steam, right? So where that water is converted to steam, right? So that is here you can observe. So in boiler, right? So water is there, right? So in boiler, water is converted to steam, right? So when we apply heat, right? So the primary thing is what? To convert water into steam with the when we apply what? With the help of heat, when we apply heat, right? So here this boiler wall is made with the steel, right? Steel. So as we know, so steel is an alloy. The major composition in steel is iron, right? Generally we can call as what? A boiler wall is generally made with the steel or iron, right? So if the water, whatever the water we are using to convert into steam, if the water is hard water, that may contain dissolved salts, dissolved salts, right? So when we continuously applying heat, right? So water starts evaporation so that the dissolved salts concentration increases, right? So due to dissolved salts concentration increasing, that may leads to formation of precipitates, right? So those precipitate may leads to formation of scale, formation of sludge, right? So these sludges and scales affects the function of boiler, affects the walls of the boiler, along with function also affect the walls of the boiler, right? And we add chemicals, in particularly in internal treatment of boiler feed water. We add some chemicals to soften this boiler feed water, whatever the water is there inside the boiler, to soft this water, to remove the dissolved salts, we add some chemicals, right? So due to that chemicals also, this boiler wall may get effect, right? So those all are comes under what? Boiler troubles, right? So boiler troubles, today we are going to cover scale, sludge and caustic embrittlement, right? So these three we are going to cover. Along with these three, other are also there like priming and foaming. So those we are not going to cover, right? So here you can observe the principle of boiler, right? So this is what the boiler, here water is there, right? So we are giving heat so that water is converted to steam, right? So here you can observe these are a small scale boilers. So you can observe here. Yeah. So scale and sludge formation. So when water is evaporated in boilers to produce steam continuously, the concentration of the salts present in the water increases progressively. The concentration of the salts, dissolved salts, the concentration of the dissolved salts, already existing salts in the water, right? So present in the water increases progressively. As the concentration reaches a saturation point, the salts are thrown out of water as precipitates, right? So those precipitates either sludge or scales, either sludges or scales, right? So sludges are loose slimy precipitates, whereas scales are strongly sticking to the inner walls of the boiler, right? So two chances are there when the precipitates thrown out. One is what? Formation of sludge. Other one is a formation of scales, right? So reason for formation of sludges and scales: number one, the solubility product, right? Solubility product of the salt must be exceeding by the product of concentration of constituent ions by which the salt is made. The solubility product of the salt is what? More, exceeding, right? So that is one reason. Second reason, when the temperature arises, so we are raising the temperature continuously. When the temperature arises, the solubility of the salt decreases, right? So in boiler, obviously continuously we are raising the temperature so that the solubility of the salts decreases. That is another reason. And next reason is the increase in the temperature can lead to reactions that result in the formation of insoluble product, right? So reactions are taking place, side reactions, another reactions are taking place. So due to those reactions, some insoluble products are forming. This is also happening due to raise in the temperature in the boilers. Yeah. So sludge formation, right? So sludges are what? Sludges are nothing but these are loose slimy precipitates. They are thrown out when we are giving continuously temperature, right? So after, when we continuously give temperature, water gets evaporated, right? Water gets evaporated, the concentration of the dissolved salts increasing, so that precipitates are forming. If that precipitate is a loose semi precipitate, right? So those are called as sludges. So majorly magnesium salts are responsible for sludge formation. Yes, few other salts are there, like calcium salts are also there, right? But majorly magnesium salts. Here you can observe magnesium carbonate, magnesium chloride and magnesium sulfate. Chloride, sulfate and carbonates of magnesium are generally responsible for scale formation, and also calcium chloride is also responsible for sludge formation. So here you can observe, right? So precipitates you can observe, right? So loose slimy precipitate is called as what? Sludges, right? So here these sludges can be removed by simple blow down operation, right? So removal of sludges can be removed by blow down operation. What is the blow down operation, right? So blow down operation means suddenly opening the gates or suddenly opening the doors, right? If you open suddenly the door of the boiler, right? So here, right, so if you open suddenly the door of the boiler, whatever the precipitate is there, that precipitate will come out, right? So that operation is called as what? Blow down operation. Yeah. Next, scale, right? So scales are hard deposits formed by the evaporation of hard water in boiler, right? So as we discussed earlier, so when we continuously give heat, water gets evaporation, some salts will thrown out. Those salts, those precipitates are two types: sludges and scales, right? If that is a loose slimy precipitate, that is a sludge. If that is a hard deposit, that means that form a extra layer inside the boiler wall, right? So that extra layer which is othering strongly, so those are called as what? Scales. These are hard deposits, right? So what happens when scale formation takes place, right? Due to the scale formation, boiler, more amount of heat has to be supplied. More amount of heat we need to supply, because so usually boiler wall is having only one wall, that is what iron made or steel made wall, right? So when an extra layer is formed, and assume this is a boiler, right? This is a boiler wall made with iron, right? An extra layer is forming, an extra layer is forming, right? So that now we need to give temperature, more temperature we need to give, because we need to heat this wall and also we need to heat this extra layer. Then only water gets starting what? Water gets reaches its boiling point and starts getting evaporation, right? So we need to supply more amount of heat, right? So due to the overheating of the boiler, due to the overheating of the boiler, certain areas of the boiler weaken, certain areas of the boiler weaken. That leads to breaking of the boiler in high pressure boilers, right? So causes for scale formation. What are the causes for scales formation? Some of the salts mainly responsible for scale formation are here: calcium based salts, calcium silicates, calcium sulfates, right? And magnesium hydroxide. So in sludge formation, major responsible are magnesium based salts. In scale formation, major responsible are calcium based salts and also magnesium hydroxide, right? So here you can observe, right? So this is a boiler wall, this is a boiler wall, right? So water is there, right? We are giving continuously heat, we are giving continuously heat, right? So after water getting evaporation, an extra layer, an additional layer forming, right? So that is a hard adherent coating on inner walls of the boiler, that is called as what? Scale. So this is called as what? Scale, right? Now we need to give heat for the water, we need to give for this iron and also we need to give heat for this scale. Yeah. So reasons for scale formation. First reason, decomposes of calcium bicarbonate. Decomposes of calcium bicarbonate. If the dissolved salt is calcium bicarbonate, right? So boiler, water is there, hard water is there. If that hard water contains calcium bicarbonate, right? So when we are applying heat, that calcium bicarbonate decomposed into calcium carbonate, right? As we know, calcium carbonate is the most insoluble precipitate. This arrow indicates what? Precipitate, right? Calcium carbonate is the most insoluble precipitate, right? So along with calcium carbonate, magnesium hydroxide can also form what? Sludges as well as scales, right? That means if calcium carbonate is forming, right, that leads to formation of scale. And if magnesium hydroxide is forming, right, magnesium hydroxide forms when magnesium bicarbonate is there, right, that also leads to the formation of scales, right? So decomposition of calcium sulfate, solubility of calcium sulfate salt decreases with increasing in temperature, right? If calcium sulfate is there, we are raising temperature, right? The solubility of this salt decreases, right? So that leads to formation of scale. Next, magnesium chloride, right? So magnesium chloride, right? So again what? Heating. If magnesium chloride salt is there, again we are getting what? Magnesium hydroxide precipitate, right? So presence of silica, right? So silica present in water gets deposited as a calcium silicate, and silica, calcium silicate and silica, right? These are also what leads to formation of hard scales, right? Removal of scales. How to remove these scales, right? So there are two methods. One is a mechanical method, another one is a chemical method. Second one is a chemical method. Chemical method. Right. In mechanical method, scales can be removed by using scraper or a wire brush. Scraper or wire brush. With the help of scraper or a wire brush, right? So scales can be removed. And another method is giving a thermal shock. That means raise the temperature suddenly or decrease the temperature suddenly. That is called as what? Thermal shock. Right? So here either take the help of scraper or wire brush or go for what? Giving thermal shock. That means raise the temperature suddenly or decrease the temperature suddenly. Next method, chemical methods. So chemical methods means here add some chemicals to the boiler water. Right? So here chemicals like HCl, EDTA and magnesium oxide. Chemicals like HCl, EDTA, magnesium hydroxide add, right? So these can remove some specific scales, right? So HCl can remove calcium carbonate based scales, right? So take dilute HCl, 5 to 10% of dilute HCl, right? So this dilute HCl can remove whatever the scale formed due to calcium carbonate. So those scales can be removed by HCl. And EDTA, so EDTA can remove the scales formed due to calcium sulfate. So calcium sulfate scale can be removed by adding EDTA. What is EDTA? Ethylene diamine tetraacetic acid, a complex forming reagent or ligand, complexating ligand or complexating reagent, right? So after adding EDTA, we can remove calcium sulfate scale. Next, magnesium oxide, right? So the silica content, if the silica content is there, silica content means SiO2 and other silica based scales can be removed by adding magnesia, right? So three chemicals we are adding, HCl, EDTA and magnesia. These are specific for particular scales. Yeah. So disadvantages of scales and sludges. What happens when scale and sludge forms, right? Number one, first point, wastage of fuel, because we need to give what? More heat. So that we need to use more fuel. First point, wastage of fuel. Second point, lowering of boiler safety, right? So when we give more heat, boiler valve may get weak, right? Explosion may take place, right? Next, decrease in efficiency of boiler. Yes, boiler efficiency, boiler may not work properly, right? So boiler efficiency decreases. And the danger of explosion, when we give overheating, that may lead to what? Explosion of the boiler. Next, differences between sludges and scales. Yeah. So first one, sludges are what? Loose, slimy deposits, whereas scales are hard and stick to inner walls of the boiler. Next, easy to remove by blowdown operation, whereas here not easy to remove. We need to go for either mechanical method or chemical method. Next, third point, sludges can transfer heat to some extent, whereas scales are bad conductor of heat. That's the reason we need to give what? More heat. Next, formed by substances like magnesium chloride, calcium chloride and other magnesium salts like magnesium sulfate, magnesium carbonate, right? So formed by substances like calcium sulfate, calcium silicate, right? And magnesium hydroxide. Next, formed on colder portion of the boiler. Sludges formed generally on colder portion of the boiler, whereas scales formed on a hot portion of the boiler. So when we compare both, these are less dangerous. Sludges are less dangerous, where scales are more dangerous. So this is differences of between sludges and scales. And third boiler trouble today we are going to cover is caustic embrittlement, right? Caustic embrittlement is the phenomenon in which boiler metal boiler material boiler material becomes brittle due to the accumulation of caustic substances. Caustic substances means basic substances, right? That is a increased concentration of alkali. Increased concentration of alkali. Alkali means bases. Alkali means bases, right? So this phenomenon happens when the boiler feed water pH raises, right? So generally normal water pH is around 7.5, right? But when the boiler water pH raises, right? So this raising in pH happens due to addition of some chemicals in internal treatment, right? In internal treatment method, we add sodium carbonate. We add sodium carbonate. In internal treatment method, there are many chemicals we add. In phosphate conditioning, sodium phosphate we add. Calgon conditioning, in calgon conditioning, sodium hexametaphosphate we add. And in colloidal conditioning, tannins, agar-agar gel we add. So like that methods, another method is there, that is a carbonate conditioning. That is a carbonate conditioning, right? So in internal treatment method, right, the basic principle is first you supply water to the boiler, then add some chemicals. First you give water, then add some chemicals. These chemicals will react with the reacts with the dissolved salts and soften that water, right? So here among that, one chemical is a sodium carbonate. Sodium carbonate. If this sodium carbonate, if we add excess of sodium carbonate, if we add excess of sodium carbonate, right? So this sodium carbonate, that excess sodium carbonate reacts with the water, right, and forms sodium hydroxide. Sodium hydroxide inside the boiler, right? So sodium hydroxide is what? It is a base. It is a base, right? Alkali, right? Now the pH of the water raises, right? So that boiler wall is made with iron or steel. Steel also having what? Steel is nothing but iron based alloy, right? So there is a chance of having fine cracks in the boiler wall. There is a chance of having fine cracks, or in the corner areas, in some corner areas, this sodium hydroxide either enters into these fine cracks, right, or deposits at the corner areas. So that what happens here? Unequal distribution of this base, this sodium hydroxide takes place. That means in the boiler feed water, right, at some regions of the boiler wall, right, sodium hydroxide concentration is more, and at some regions of the boiler wall, sodium hydroxide concentration is less, right? So that leads to formation of a concentration cell, development of number of concentration cells. What is concentration cell? So in concentration cell, when the electrolyte concentration differs in in region to region, that leads to development of a concentration cells, right? So sodium hydroxide attacks the boiler material, and iron of boiler dissolves as a sodium ferrate, right? So that sodium hydroxide reacts with the iron. This iron, what? This iron is a boiler wall. So this is a boiler wall. When sodium hydroxide enters into fine cracks of the boiler material is made with iron, reacts with that iron, forming what? Sodium ferroate. Right. The whole process can be explained by considering formation of concentration cell. Iron surrounded by dilute sodium hydroxide behaves as cathode, right? So a cell means there are two regions, anodic region and cathodic region, right? So dilute sodium hydroxide region iron behaves as cathode, and iron in contact with the concentrated sodium hydroxide. Iron with the concentrated sodium hydroxide acts as a anode. Right. So now two cells are developed, anode and cathode. Right. As we know, at anode, oxidation takes place. Oxidation takes place. At anode, oxidation takes place. At cathode, reduction takes place. Right. So oxidation means here what happens? Iron. Right. So boiler wall is made with iron. That is going to lose its electron. That is going to form a ion. That means boiler wall is nothing but it is in metallic form. Right. Now it is converted to ionic form. So disintegrating, boiler wall is disintegrating. Right. So sodium ferroate is forming what? Fe3O4. Right. Magnetite. Right. So see the here cell formation. So this is a anode. Right. And this is a cathode. Right. So here disintegration is going to take place at this region, because oxidation is going to take place here. Right. So this is nothing but boiler corrosion. Right. So due to addition of excess of sodium carbonate leading to formation of sodium hydroxide when that reacts with water, right, that formed sodium hydroxide is entering into fine cracks of the boiler, reacting with those fine cracks, right, for that iron is converted to sodium ferroate, right, because there are anode and cathode regions are developing, right, number of concentration cells are developing, right, so that leads to formation of rust, nothing but boiler corrosion, right. So prevention, how to avoid this caustic embrittlement or boiler corrosion, how to avoid this? Use a sodium sulfate as a softening agent. That means avoid using sodium carbonate, avoid using sodium carbonate, go for using of sodium sulfate, right. So that is one method, because that, yeah, so sodium sulfate also blocks hairline cracks, right. Next, adding tannin lignin, which also blocks hairline cracks. So first you block the cracks, whatever the cracks are there inside the boiler wall, you first block those cracks, then you go forward using of sodium carbonate. That is one method. Another method is go for what? Directly using of sodium sulfate instead of using sodium carbonate. Thank you.